And so once again, I'm making this up on the fly. How about 435 degrees? What is the terminal angle on 435 degrees? And once again, they're asking you to take out 360 as many times as you can, or zip around as many times as you can. So here is once, so we just took 360 out. Now what's left? Well, okay, so incidentally, you're going to need a calculator for this class. Scientific one, TI-83, the good calculators, they're great. However, this $15 calculator will be fine. I just did 360 degrees. How much is left as I go over? Well, it's going to be 435 degrees minus 360 degrees. And yes, I actually can do this on the board, but I'm lazy. I've just been lecturing all day. 5 minus 360. This says it's 75 degrees. So basically, now we go another 75 degrees. What's a good representation for 75 degrees? Well, I know that this is 90. So 75, so here's splits the half. This is 45. 75, I'm just going to pretend is right about here. And this angle right here is 75. This is the terminal angle. Once again, pretty much this is, if this seems strange, based off the clock. I mean, really, this is just going military time. What's 1,300 hours? Chip, cameraman?
1 o'clock.
1 o'clock. Why is that? Because it went around 12 hours and it's back to where it was. 12 plus 1 is 13. It's similar to this. And now, Chip, I'm going to have to get you to sign a release form because you're now part of this movie. Let's do something else. What is the terminal angle of... Oh, let me put it here. See, if I had some students in the class, minus 37 degrees. What's the terminal angle on that? So what are we going to do? Well, coming to our grid system here, the x-axis, minus 37 degrees, I can do this. It goes down here. So this is minus 37 degrees. So I just made it up. How did I make it up? Well, 37 is a little less than 45. What's the terminal angle here? Well, what they're asking is, what is this around this way? When you talk about terminal angle, you want to write it in positive notation from 0 to 360 degrees, which actually we're not going to do much longer because I'm going to talk about radians and radian measure. But so what are we going to do? We're going to go here and come around to here. So this is the angle. The angle is all of this right here. And how much is that? Well, an easy way to do it would be just do this. This is 360 minus 37 degrees. You should put the degrees there. I'm going to be lazy now. This is like welcome, we're back. This is the second section of lecture number 1, and we're going to talk about radians. And what is a radian? Well, a radian is another unit of measure that's a little better in general for physics and mathematics than degrees, because radians are a unitless measure. And specifically, I'll do my best to draw a radian here. Here's your circle, here's the unit circle, and by unit I mean that the radius is 1. This is the 0.1, but don't worry about that for right now. A radian is, so in general we have this equation, theta, this is called theta, and this is another Greek letter, this is equal to S divided by R. And right away somebody's eyes just rolled, I could hear it. What is S? What is R? R is the radius. S is arc length. What specifically is that? So I'm going to draw this picture right here. So here's the R, here's the radius, and we're on the unit circle, right? So I'm going to say that R is equal to 1. The arc length is this distance right here, from here up to here. Okay? So this is what they did. Instead of using degrees to measure angles, What they did is they said is that this in radians, which is unitless, and somebody's just going, if it's unitless, how come it has the name radians? Well, we got to call it something for the angle, and I'll explain the unitless in a second. It is this arc length divided by this length. So this 1 radian is when the arc length and the radius are the same, is when S over R is equal to 1. This is about, 1 RAD. This notation is typical. For radian measures, RAD is often used. There are several other things that are used, but I will probably stand with this. So 1 radian is about 7 degrees and some change. Actually, I'm going to explain how to calculate it right now. I think it's about 57 plus change degrees. I'll show you exactly how to figure it out. Incidentally, somebody's going, what's that? In mathematics, when something is not necessarily equal but approximately, we put this little squiggle up there. This means I'm approximately equal to. Just like pi, we know that pi is a transcendental number. Hopefully your algebra teacher told you that, which means that the decimal places going off to the right never repeat themselves. But we often say that pi is approximately 3.14. So it turns out, let's see, what can I take out? I guess I'll put it over here. There are 2 pi radians in a circle. So if we go around here one time, this is 2 pi radians. That makes, so just by dividing things up, so this is still 0 radians. This is 90 degrees, which is a quarter of 360. How many radians is this? Well, this is a quarter of this. Just to do some quick math, 2 pi over 4, that's a quarter of that. This is the same as pi over 2. So, and these are very important. Pi over 2 is 90 degrees. And 0 radians is the same as 0 degrees. In general, we are going to be always doing radians because in physics in particular you need to. However, a lot of these things, it's just a lot easier to think about in degrees. So for these basic things, it's really good to know the radians and degree measure. This is 180 degrees. This is pi radians. This is 270 degrees. It's a terrible 2. And this is going to be 3 pi over 2 radians. And then back over here, this is 2 pi radians. So what's the conversion? How do you figure this out specifically? Well, as somebody has probably already thought, and I guess I'm going to have to get rid of some of this over here. We know that there are 2 pi radians per 360 degrees. Maybe I'll write degrees. So this is a unit measure. Remember, like 1 foot over 12 inches? This is a unit. This is just 1. Multiplying by this only changes the units, all right? 2 goes into 360. I can write this as pi radians over 180 degrees.